Membogram again. Let's look at a problem with C and C++ that doesn't seem to have a real solution yet. But if it creeps into your code, it'll be difficult to find and it's not much fun. A lot of times a compiler will tell you there's a duplicate definition and you ignore those compiler warnings. And therein lies a joke after you've spent 2 days finding the error. All right, let's go ahead and create it so we can see it. Let's do it. All right, so over here, let's look at create a structure we're going to duplicate in a bad way. All right, so we have a structure. Let's just call it Z. We'll create it 48 bytes over here and then whatever. So we'll have it in the main. It'll be compiled into this main object and there will be a copy in the main. Main will have an idea of how big it is, and then we can set ch through these functions. We can set it through z3, which will be in our second object file, which has a different definition. And then we can check that overflow, check variable right there, which we set, let's say, to 3. And if it doesn't crash, it'll at least tell us there's an error. Sometimes it'll just crash because you're off. Anyway, so these are the functions defined in z3.c that I defined, and they have a different definition of that structure, a different size of ch. So again, when we copy here, that's going to be bad for our structure. Then when we run this check, we'll at least catch it. This check being right here. All right. So let's see. Let's go over to Z3. We see that we have 4 bytes in ch. 4. Not 48, not 47. Yeah, there's a different definition. This is bad. You would think that C is going to give us a error message. It will not. Let's see. Here are functions. Well, one of them is just to check the overflow and return. Anyway, let's go ahead and run it. Compile it and run it. So there's two ways we can run it. Let's go ahead and just do the gcc main.cpp c3.cpp. All right, so I put main first. That means in the executable, main's definition of that object is the one that exists, the one that has a priority. So anyway, that's one thing to think about. And then we have our 2 trace statements there. There's the first one where, everything's good. And then in the second one, when we set it from main, our overflow check failed because we had a different function definition. Notice there was no compiler warnings. No compiler warnings, because it's at the linking stage. There's 2 different definitions found during the link. All right, how does this creep in? Well, you might actually copy that off into a different library, or someone else did, and then the definition changed over time, or they got out of sync. Any way. There's a couple of different ways it could happen. Someone just made a mistake and modified it in one place and not the other, thinking that it's good practice to only have it defined in one place. Yeah, that would be a reasonable assumption. And there you are. All right. Well, there's your error. And again, you can look in the II files if you wanted to actually see how they were defined in each one. GPP, save temps. Oops. Get C3. I forgot to do the minus C. Anyway. So then in II, you'd see that you have a definition of 48 there and not the 4. And then the other one, when it gets compiled, will have a different definition of that structure. All right. Thank you very much. Good luck.